Here 41, f evaluate at 0 is 0 over 0 squared plus 1 is 0 over 1 is 0. F evaluate at 1 is 1 over 1 squared plus 1. The 1 over 1 squared is 1 plus 1 is 2, 1 half. A negative 1. F evaluate at negative 1 is negative 1 over negative 1 squared plus 1. In the top we have negative 1. In the bottom we have negative 1 squared is positive 1 plus 1 is 2. It's negative 1 half. F evaluate at negative x is negative x over negative x squared plus 1. Negative x stay and negative x squared positive x squared plus 1. Now negative f negative x, no, positive x. It's negative outside, this is negative, and you copy identical the original function. And by the way, this and this are the same thing, because when you have a fraction you put negative in the top, it's the same put the negative in the middle or in the bottom. Okay, now f evaluate at x plus 1 is x plus 1 in the top over x plus 1 squared plus 1. And you expand, this is x plus 1 in the top, and the bottom is x squared plus 2x plus 1 plus another 1. Entonces you combine, is x plus 1 over x squared plus 2x plus 2. This is the answer to 41. Well, no, not the answer. You need to evaluate 2 more cases. Okay, let me erase this part. Okay, f evaluate at 2x. Replace 2x over 2x squared plus 1. This is 2x over, and this is 4x squared plus 1. And finally is f evaluate at x plus h is equal x plus h over x plus h squared plus 1. So in the top stay x plus h, in the bottom we have expand, this is x squared plus 2xh plus h squared plus 1. And this is that. Okay, 43. Evaluate 0. Absolute value 0 plus 4 is 4, because absolute value 0 is 0. Evaluate at 1. Absolute value 1 plus 4 is 1 plus 4 is 5. Absolute value negative 1 is absolute value negative 1 plus 4. Again is 5, because absolute value negative 1 is positive 1. F evaluate at negative x is equal absolute value negative x plus 4 is equal absolute value x plus 4. Exactly the same, the original. And a minus f of x is minus absolute value x minus 4. Now f evaluate at x plus 1 is absolute value x plus 1 plus 4. F evaluate 2x is absolute value 2x plus 4. You can leave it like that, or you put absolute value, the product is the multiplication, absolute value 2 is 2, absolute value x plus 4. And f in x plus h is equal absolute value x plus h plus 4. And leave it like that, no more, no more is possible to do that. Okay, 45. Again, f evaluate at 0. Plugging in. 2 times 0 plus 1 over 3 times 0 minus 5. Is 1 in the top and negative 5 in the bottom. The answer is minus 1 over 5. F evaluate at 1 is 2 times 1 plus 1 over 3 times 1 minus 5. 2 times 1 is 2 plus 1 is 3 over 3 times 1 is 3 minus 2 and negative 2. The answer is minus 3 half. F evaluate at negative 1 is 2 times negative 1 plus 1 over 3 times negative 1 minus 5. Negative 1 times 2 is negative 2. Negative 2 plus 1 is negative 1 over negative 3 and negative 8. And negative divided by negative is positive. 1 over 8. Okay, now f evaluate at negative x is 2 times negative x plus 1 over 3 times negative x minus 5. Entonces basically is negative x is equal minus 2x plus 1 over minus 3x minus 5. There is one possibility to express the answer. Another possibility is multiplied by negative 1 top and bottom. Entonces you have 2x minus 1 over 3x plus 5. Basically I multiply by negative 1 here, by negative 1 here, and negative 1 divided by negative 1 is positive 1 because it's exactly the same, nothing. And a minus f and negative x. Wow, this is different. This is change the sign, it's a negative and copy identical the original. Okay. Now the two last. Is f evaluated to x. Is 2 times 2x plus 1 over 3 times 2x minus 5. Is 4x plus 1 over 6x minus 5. Super. Now f evaluate at x plus h. This is 2 times x plus h plus 1 over 3 times x plus h minus 5. Now distribute 2x plus 2h plus 1, 3x plus 3h minus 5. I'll leave it like that and the answer. Okay, 47 and the rest is find the domain of each function. Let me recall something. Recall. The restriction on the find the domain is when you have a fraction, p over q, and the restriction must be the expression in the denominator not equal to 0. This is the first one. And the second one is when you have a radical, the expression inside the radical must be non-negative. And of course, they are combination. If do not exist this, the domain is all real number. That's it. For example, 47 is elementary. F of x is equal minus 5x plus 4. Es a linear function. Entonces es obvio que el domain of the function f is all real number. That's it. 47. 49. Well, 49 is different because we have quotient. When you have quotient, this is 49, f of x is equal x over x squared plus 1. You take the expression and the denominator, and this expression must be different to 0. And you try to solve this inequality or equation. Let's convert to equation. I like to convert to equation. it's the negation of this statement. Entonces x squared is equal to minus 1 square root both sides, and the answer of course is plus and minus I, que es imaginary number. What is the interpretation of that? The restrictions are imaginary number. So inside the real field we have no restriction. Then domain again of the function f is all real number. Okay, 51. 51 again we have a fraction, and you take the expression in the denominator, and this expression must be different to 0. I convert it to equation, que es the negation statement, and I solve this equation. Quadratic equation using square root principle. X is equal plus or minus 4. So what is the conclusion? The conclusion is the domain for the function g is all real number such that satisfy this condition. Must be different to positive 4 and must be different to negative 4. That was 51. 53. 53 is similar. Okay, let's do 53 here. It's easy. 53 is capital F of x is equal to x minus 2 over x cubed plus x. Again, we have a fraction. You take the expression in the denominator, must be different to 0. You convert it to equation and solve this equation. This is a factorial equation. A greater common factor is x. We have x squared plus 1 equal to 0. Now each factor is equal to 0. This is sum of square. It's no factorial expression. So one factor is x equals 0 and another factor is x squared plus 1 equal to 0. But unfortunately the answer of this part is imaginary. Let me see. I bring negative 1 to the other side. When you take out square root both sides, it's plus or minus I. No, I don't want imaginary in this part. Now the domain for the function capital F is all real number except 0.